Welcome to physics class. In this video, I'm talking about scalar and vector quantity. If this is your first time visiting my channel, kindly pause this video and go back to the previous video. Check all the video I've made right from the introduction of scalar and vector quantity. But in this case, I'll be talking about components of vector. So as far as components of vector is concerned, vector they are usually described in terms of their vector components or in terms of their components, be it the horizontal component or the vertical component. But the components of vector is actually represents as both x and y. The x-axis represents the x components, while the y represents the y components. The x component is also called the horizontal component, while the y is called the vertical component. So what happens in this case is that, let's say I have a diagram, right? I have a diagram, right? So in this case, to represent the components of vector on this diagram, this side is taken to be the x-axis, right? And this side is taken to be the what? Y-axis. But let's say vector A is acting in this process. Here I will happen to be AY, and here I will have to what? AX. AX represents the x component, while the AY represents the y component of a vector, right? So to calculate the component of a vectors in this case, we are going to have the vector A to be equal vector AX component plus AY component, right? So it means that whenever we have two components of vector, which is x and y, right, acting at angle 90 degree to each other, the component or the resolution of the vector is going to be ax plus ay. That is the sum of both the x and also the y components. Then let's check structure B, right? So this structure B, let's say we have the same angle in this case, right? So in this case, what I'm going to actually represent structure B as is I'm going to denote the unit vector we can have as far as ax and ay is concerned. So it is common to denote the positive x-axis as I, right? And it is common to denote the positive y-axis as j, as far as two components of vector is concerned. Then in this case, simply this side is taken to be ayj, right? And this side is taken to be axi. So here I'm considering the unit vector. And what is unit vector? Unit vector is just they are the vector that they have their magnitude to be equal 1. So both I and j in this case is equal 1. So here I'm going to have the resolution of the components to be vector A, which is equals to axi, right, plus ayj. So that's the case for the second diagram. Then let's say we have the third diagram in this case. So this third diagram, I'm going to use it in three directions. That is, I will represent it as three components of vector, which is which is x component, y component, and z component. Right? So here, let's say I have a diagram, right? The diagram is acting in three components, which is similarly known as space, right? So here in this case, this will be our x component, this will be our y component, and this will be our z component, right? So it is to denote each and every component in their unit vector. I'm going to represent this as xi, right? And this to be yj. Likewise, this to be what? Zk. right? So here both x, y, and z are acting at a particular angle to each other, right? So in this case, to calculate the resolution of vector, here I'm going to have it to vector a to be equals to az axi, right, plus a yj, right, plus azk. But you guys need to know that your I, j, and k, they are known as unit vector and their magnitude is equals to 1. So after that, in 3 dimension, the vector A has 3 components. In 2 dimension, the vector A has 2 components, as you can see. But in 3 dimension, the vector A have 3 components, which is x, y, and z. Right? So now let's consider, let's say we are asked to find the magnitude of vector A, right? We are asked to find the magnitude of vector A if let me just say A is equal 2i plus 3j plus 5k, right? So in this case, we are asked to find magnitude of vector A if A equals to 2i plus 3j and plus 5k. So in this case, to find the magnitude of vector A plus 5k, so here is my x, here is my y, and here is my z, right? So to find the magnitude in this case is going to be, that's roots of ax squared, right, plus ay squared plus, that's actually az squared. So it is either plus or minus if the case is actually negative, but if it is positive, you can go ahead and use it like this. So after that, let's say we are asked to find the magnitude of vector A in 2 dimension. In finding it in 2 dimension, we are going to have it to be magnitude of vector A to be equal to root of axi plus ayj. And don't worry, this is going to have squared. This we have squared, right? This is to find the components of vector in 2 dimension or 2 components. So after that, let's go ahead and input this. In this case, our ax is equal, ax in this case is equals to 2, ay in this case is equal 3, and az is equals 5. And what you need to make note is that whenever we are asked to, we are dealing with magnitude. Magnitude doesn't take into consideration the sign in front of vector. So if this is negative, if you take the magnitude, it will still turn towards positive. If this is negative, if you take the magnitude, it's going to turn to positive, right? So the magnitude of vector A in this case is taken to be root of ax is taken to be 2 squared plus 3 squared plus 5 squared, right? Then I'm having magnitude of vector A to be equal root of 4 plus 9 plus 25, right? So in this case, my magnitude of vector A is taken to be root of, that's 13 plus 25, right? Then I'm having it to be root of 28, right? Root of 38 rather, 25. That's actually root of 38. The magnitude of vector A in this case is taken to be root of 38. So that's just it. So whenever you are asked to calculate for the magnitude of a vector, you don't need to take into consideration the unit vector of each component, right? And also the magnitude doesn't take into consideration of the sign in front of the word vector, right? That means it doesn't take into consideration of the direction in front of what of the vector. So after that, let's say we are asked to calculate for, let's say we are given that if vector A equals to I plus 4k, right? We are now asked to find the magnitude of vector A. In this case, as you can see, this is actually 2 components, right? And the magnitude of vector A is taken to be what? To take to be axi all squared plus ayj, right? All squared, as far as 2 components is concerned. Then here we are going to have it to be magnitude of vector A equal root of, here our AXI is taken to what? 1, because the magnitude of what of I is 1, which means I'm going to have this to be I squared plus here is actually 4, right? Which is 4 squared. Then here I'm having it to be what? Magnitude of vector A equal root of, that's 4 squared is actually 16, right? Then plus 1, that's root of 17, right? And root of 17 is taken to be, I think that should be 4.123 units, right? So we can have it to be unit, because we are dealing with what? Magnitude. It has no unit except unit here, right? So let's say we are asked to find the direction now. The direction is taken to be tan theta equal ay over ax, right? So here I'm going to have to be theta equals to tan inverse of ay over ax, right? So here what I actually need to consider is that I'm having theta to be equals to tan inverse of what is my ay and what is my ax. So in this case, my ay is taken to be 4, right? Then divided by ax, which is taken to be what? 1. Then I'm having it to be theta equals to tan inverse of 4. So tan inverse of 4 give me 75.96 degree. So that's the case. If you find this video helpful, kindly click on the subscribe button and don't forget to drop your comment in the comment section below. Thanks for watching.